Hello viewers, in this video lecture we are going to see one topic, causal networks, from the second unit of artificial intelligence and machine learning. The objectives are to understand about the concepts of causal networks and to understand how causal networks are used to represent knowledge in AI. Causal networks illustrate the causal dependencies of all the components in the network. A causal relationship exists when one variable in a dataset has a direct influence on another variable. Thus, one event triggers the occurrence of another event. A causal relationship is also referred to as a cause and effect. The ability to identify truly causal relationship is fundamental to developing impactful interventions in medicine policy, business, and other domains. Often, in the absence of randomized control triads, there is a need for causal observational data. So, the causal networks are used to show the correlation between the variables. Neither causes the other is the presence of confounding variables. For example, smoking causes lung cancer is not about a particular smoker, but states a special relationship exists between the property of smoking and the property of getting lung cancer. A causal statement this says more than that there is a correlation between two properties. So some causal conditions are necessary conditions. For example, the presence of oxygen is a necessary condition for combustion. In the absence of oxygen, there is no combustion. So the cause is often used in this sense when the elimination of the cause is thought to eliminate the elimination of effect. And this is associated with structural causal models. It represents the causal dependencies using graphical models that provide an intuitive visualization by representing variables as nodes and relationship between the variables as edges in a graph. It is a framework unifying graphical models, having the structural equations and counterfactual and interventional logic. And another one way of representing the causal networks is by using the directed acyclic graph, that is Bayesian networks. It is a collection of nodes and edges. Nodes will represent some objects. Edges between the nodes shows the interconnection between those objects. The edge is orientated from one node to another node. In a directed graph, the edge goes from a parent node to a child node. A path in the directed graph is a sequence of edges such that the ending node of each edge is the starting node of the next edge. And this is the example for a simple directed acyclic graph. So in this graph we can see A having the children B and C. And there is E, G, F. In between E, G, F there is a cycle. Another node is isolated node. And Bayesian networks are used for the probabilistic reasoning. So it is called as probabilistic graphical model that represent the dependency structure of a certain set of variables and their joint distribution efficiently in a factorized way. So in Bayesian networks, the link between the variables shows the dependency but not necessarily causality. Hence, the edge between the node should be seen as cause-effect relationship. So in this diagram we can see the sale scenario in a bank with a customer. A Bayesian network. The previous diagram is the Bayesian network describing a banking case study. New sales and the number of meetings with a customer directly affect the bank's income. However, these two drivers are not independent, but the number of meetings also influences whether a new sales takes place or not. In addition, system prompts indirectly influences the bank's income through the generation of new sales. This example shows the B and Bayesian networks are able to capture complex relationship between the variables, and it is used to represent the interdependent dependencies between the drivers and include drivers that do not affect the target directly. Now let us see the steps for working with the Bayesian networks. Bayesian networks models are built in a multi-step process before they can be used for analysis. First one is structural learning, structural review, likelihood estimation, prediction and inference. So as we told, Bayesian networks having many advantages. They provide a graphical representation used for reasoning. Relationships captured between the variables in a Bayesian network are more complex, yet hopefully more informative than a conventional model. The probabilities of variables in a Bayesian network update as observations are added to the model. So in this way, causal network is a advanced concepts of Bayesian networks.